And here we go. So, why is that there? Okay. I don't want a grid view. I want active speaker. There we go. Okay, so last time we saw, we reviewed a little bit the decimal system. Which in theory should have been very easy, very simple. And we started looking at the binary number system. And so here's just a little quick example of what we did. So here's just to refresh your memory. There we go. So let's say that I write 101.11 like that. That means that it's written in binary. So what does that mean? So of course it's a positional system. So these are the powers of 2, starting from 2 power 0, increasing to the left, decreasing to the right. So this will be 1 times 2 power 2, plus 0 times 2 power 1, plus 1 times 2 power 0. So this is the integer part. And then 1 times 2 power negative 1, plus 1 times 2 power negative 2. So this is 4 plus 1 plus 1/2 plus 1/4, which is 5.75. Correct. In decimal, right? So these are just 2 ways of writing the same thing, binary and decimal. Okay, so now today what I want to do is to see how we can convert. So converting decimal to binary. Now, of course, as I said, I'll start repeating this, but just in case you just miss that part every time. Of course, this can be done with a calculator in half a second, right? The point here is not to actually it's not getting the result. The point is understanding how we go from one to the other to see. So later on, this will be important. And also to understand the efficiency or non-efficiency of the algorithms that deal with these numbers. So let's see how we can go from decimal to binary. You actually have to split this into 2 different parts. For the integer part and the fractional part, the method is completely different. Okay, so different algorithm for the integer part and the fractional part. Okay, so let's start with the integer part. Okay, so to illustrate what I'm going to do so that you understand a little bit what's going on, I'm going to do it in decimal. So it's going to look really silly, but basically that'll give you the algorithm. You'll understand the algorithm, why it works when we go to binary. So to illustrate the whole method, I'm going to convert a decimal number to decimal. That sounds really stupid, right? But it's just to illustrate the method. Okay, so here's an example. What I'm going to do is I'm going to take the number 582 in decimal, and I'm going to try to extract the digits. Okay, so we extract the digits as follows. So these will be 6 by 10. Okay, so when we go to binary, it'll be successive divisions by 2. That's how we're going to get the bits out of the number. So let's see what happens if I just do it in decimal. Okay, So I do 582 and I divide this by 10. Okay. Again, I know that if you went to the English system, you're writing this differently, but it's exactly the same method. Again, I say that. So I divide this by 10. So 5 times 10 is 50. I've got an 8 left, bring down the 2, and then 8 times 10 is 80. And now I've reached my remainder. I talked about this last time. This is my remainder of my division. This is smaller than what I'm dividing by, which is 10, smaller than 10. So this is my remainder. I'll just leave it there, okay? Then I'm going to repeat the procedure with 58, okay? So I repeat the procedure now, 58 divided by 10. So it's recursive. So 5 times 10 is 50. That leaves 8. And 8 is less than 10. So this is my remainder. Okay. And then I repeat with my 5 here. 5 divided by 10. This goes 0 times, right? It's smaller than 10. So I just get a remainder of 5. Now, if you look at the 5 remainders you got, what do you see? You exactly see the digits 582, right? 582. Okay, so I've extracted the digits, the decimal digits of 582 by repeatedly dividing by 10. Until when? When did I stop? This is my stop sign. Okay, I've got no tens left in my divisions one after another, so I just stop. Okay, so you see that we extracted the decimal digits by successive divisions by 10. Okay. And I stopped when I got a 0. Okay. So I'm going to do this now by dividing by 2. And I'm going to get the bits out of my, so it's the same. So this is the same procedure. To get binary expansion, but successive divisions by 2. And in fact, for any base, if you were in base 7, 5, 2, 18, whatever, it's exactly the same procedure. Okay, so let's do an example to see how this goes. Okay, so let's see. So converting 109 to binary. Okay, so this is a bit longer. It's easier in a sense because the divisions are only by 2, so that's like super easy. It's longer, there are more divisions. You have to be like really, really careful when you're doing this because it's just a bunch of zeros and ones, and it just, the wrong answer and the right answer will look exactly right. For, I mean, there's no way. You have to be very, very careful with this. Okay, so let's start. So 109, I divide this by 2. Of course, you can do this quickly. I'm gonna do it like a machine, like stupidly, really slowly. Okay, so 2 times 5 is 10. I bring down the 9. 2 times 4 is 8, and I've got 1, which is my remainder. Right. This is smaller than 2, so that means I'm done with my division. What do I do next? I do exactly like I did in the decimal case. I take the 54 and I repeat. 54 divided by 2. Well, that's 27, right? You can do it in your head, but let's say I do it slowly. 2 times 2 is 4. That's 1. Bring down the 4. 2 times 7 is 14. I get a remainder of 0. This, careful, this is not the stop sign. This is the remainder. Okay, I still have something to divide with. Okay, so I repeat. 27 divided by 2. 1 times 2. Bring down the 7. 2 times 3. I get a remainder of 1. Okay, again, the numbers are small, so you can do this very quickly. Okay, so I repeat with the 13 now. 13 divided by 2. Okay, I'm going to skip a few steps here. Obviously, 2 times 6 is 12. I get a remainder of 1. Hopefully that's okay for everybody. Okay, I can't see my chat here. There you go. This is better. And then I repeat with the 6 divided by 2. 2 times 3 is 6. Remainder of 0. The 3 divided by 2. It's near the end where it gets really tricky. Okay, this is where the mistakes occur. Okay, so 1 times 2, I've got a remainder of 1. I haven't finished yet, right? Because this is not 0. So I do it again. 1 divided by 2. How many times does 2 go into 1?
0.
0, correct. So this is 0. I got a remainder of 1. And now you stop. This is your stop sign. There's nothing to do after that. Okay? So I've circled all the remainders, and that is in fact the binary representation of 109. Now, the last thing to figure out is in which order do I write these things? If you go
Opposite
back,
order.
yes. So if you look at the decimal example, you'll see exactly in which order you're supposed to write this. Okay. So it's right to left. Okay, so this is how we're going to read this, like this. Okay, so let's write it down. So I've got 1101, 101. So it's 1101, 101. I'm just going to copy that. Copy. Okay, let's just write this down. So this should be 109 in binary. Okay, so let's suppose that you're doing this on a test and you've got this number. What do? Well, you can check, right? Because it's easier to convert the other way around. So let's just take 1101, 101 and check that it is 109 in binary. So 1101, 101. So this is 0, 1, 2, 3, 4, 5, 6. 1 times 2 power 6 plus 1 times 2 power 5 plus 0 times 2 power 4 plus 1 times 2 power 3 plus 1 times 2 power 2, and just the last one, 2 power 0. So this is 2 power 6 is 64, 2 power 5 is 32, 2 power 3 is 8, 2 power 2 is 4, 2 power 0 is 1. Let's see. So this is 40, 104, 104, 108, 109. Yes, works out. Okay. So another way that you can remember in which order this goes, okay, so notice this also. Okay, so 109 is an odd number, right? So for those of you who've studied in French and might not have seen this word before, it's impair. It's not divisible by 2, okay? So it's odd. Okay, it's
Merci.
not. You're welcome. So it's not even. Not pair. Okay, so even is pair, odd, impair. All right, so 109 is odd. So when you divide it by 2, the first shot, you're going to get a remainder of 1. Otherwise, you'd get a remainder of 0. So 109 divided by 2 gives a remainder of 1, right? So the first division indicates that you have an odd number. Now write down a number in binary, okay? So that's your first division, right, that you do, okay? So when you write down a number in binary, okay, so a number in binary, right, you have a bunch of bits, let's say 1 0 1 1 0 1 1 0 1 0, let's say this. How do you check if it's even or odd, right? Think about it. This is a sum of all powers of 2. Yeah, Ethan? You wanted
Oh, I was
to...
just about to say, I think you'd look at the last digit and see if it's.
Correct. Yep. So the last bit is going to tell you if this number is even or odd, right? Because these are all powers of 2, right? So you're adding even numbers. And the last one is either +1 or +0, right? So this will say that the number is even, right? If it's a 0, and if the number were odd, if it's a 1, then it's odd. Because you're adding, you have a bunch of powers of 2 and you add 1. So you're going to get an odd number, right? So what this tells you is that the first division gives you what we call the parity bit, the bit that tells you if the number is odd or even. So the first division gives the rightmost bit, which tells you if it's 1, the number is odd, and if it's 0, the number is even. Okay, so this is a good thing to remember. And when we look at how numbers are written down or kept in memory, this will be important when we deal with integers. Okay, so there's always a bit that you can check which tells you if the number is even or odd. Okay, should I do another one or a fractional part? Let's do a fractional part and then I'll do another example after that. Okay, so this is for the integer part, successive divisions by 2. Okay, so integer part, we're going from decimal to binary, successive divisions by 2. Okay, so that's the way to do it. Okay, now fractional part. Well, fractional part works the other way around. Rather than successive divisions by 2, it'll be successive multiplications by 2, fractional part. And again, what I'm going to do is to illustrate how this works, I'm going to do it in decimal. It's going to look even really stupider than for the integer part. But this way, you can never forget how this is supposed to work. Okay, successive multiplications by 2. So to illustrate, I'm going to do it with a decimal. Sorry, I'm writing too fast and it's hard to read. So I want to extract the decimal places of a fractional number written in decimal, okay? So let's say 0.537, okay? So I'd like to get an algorithm that extracts these numbers 5, 3, and 7 one after another. So here's a way, okay? So I'm going to just keep a window on the integer part of that number, okay? So first it's 0 because I'm looking at only a number less than 1. If I multiply it by 10, I'm going to shift that point, right? So if I multiply this by 10, what do I get? I get 5.37. So if you look at the integer part of this new number, that's your first digit. That's the first guy, right? So what you do is now you remove it and you repeat this procedure with the fractional part of what you got when you multiplied by 10. So repeat. Multiply this by 10. What do you get? I mean, I know this looks really silly, right? It's just sort of obvious, but it's to illustrate the algorithm which works with any base, okay? So I multiply this by 10, it shifts the decimal point by 1. What am I looking at? The next digit, okay? And then I repeat, I remove this 3, I get 0.7, multiply by 10, I get 7.0. And what does that 0 tell you? You stop. There's nothing left to do. Okay? And you look at the numbers that popped out, and they are exactly the numbers in your expansion. Okay? So we've extracted the decimal places this way. Okay? So to do it now, to get the fractional part in binary, what will I do? I'll just multiply by 2 this time. Okay? So let's see how this works. Now, the order now, what's the, I mean, this makes sense, right? The first one you get will be the closest to the decimal point, right? So notice the first digit we get is closest to the decimal point. So that tells you in which order you're going to write this, right? I mean, obviously here, these are the same numbers. That's the way we write down these numbers. So we obviously see the order in which this is supposed to go. But when we go to binary, it's just going to be a bunch of zeros and ones, and then it's not clear in which order it's going to be. Okay, so let's take an example where we go to binary. Okay, so we're going to convert 0.78125 to binary. Okay, so this is a fraction written in decimal, and I want to write it in binary. So how do I do this? Successive multiplications by the base I'm interested in, which is base 2. Okay, so how is this going to look? Okay, so let's start. 0.78125 times 2. Let's do that. I'm not going to be lazy. I'll just do it here by hand. 2 times 5 is 10. 4, 5, 2, 16, 14, 15. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is 1.5625. Okay, you see, I get a 1 here. That'll be my first bit after the binary point. Okay, so what do I do now? I forget about this integer part and repeat with the fractional part. 0.5625 times 2. Okay, 5625 times 2. 2 times 5 is 10, 5, 12, 11. I have 4 decimal places, so this is 1.125. Okay, so I've got another one. What do? Get rid of the integer part. Sorry?
I have a question.
Yep.
What about the zero at the end?
Sorry?
1, 5.
Can you, there's a lot of feedback. I can't really hear you well. So can you turn down the sound on your computer when you're asking the question?
Yeah. You wrote 1 to 5 and you forgot the zero. You have to put the zero or can you just leave it?
Sorry, is your question is why did I not write the 0 here?
Yeah.
It makes no difference, right? It's at the end of the fractional part, so it doesn't contribute to anything. I don't need it.
Okay.
Right? It's on the right of the point, so it's a fraction. So the zeros on the right don't mean anything. Is that
okay? Thank you.
okay? All right, good. All right, so 0.125 is my fractional part. I multiply by 2. So that's pretty easy. That's actually 0.250. I can write it or not, it makes no difference. Okay, so now you see this fractional part is 0. Okay, that's not my stop sign. I repeat until the fractional part is done. Okay, so now I repeat with 0.25 times 2. This is 0.5. I won't write the zeros. Okay, now my fractional part is 0.5 multiplied by 2. This is 1 point, and I'll write the 0 now so that we can see that we stop. Right? So once the fractional part is 0, I'm done. I've gotten rid of everything I wanted. And now I can read off the bits, and this is the fractional part in binary. So now I have to remember which order do I put this in. Well, if you remember the decimal example, the first one you get is the closest to the point. So you just write them going down like that. So 0.78125 is equal to 0.11001, 11001 in binary. Okay, so it's not hard. Okay, the hardest thing is remembering it in a sense. Okay, but if you remember this trick of doing it in decimal, you can just reconstruct the whole algorithm by doing it in decimal. Say, oh yeah, okay, so now I have to do is just, rather than do it in base 10, which shifts the point, right, I just do it in base 2, and I can it'll work out. Of course we can check, right? So 0.11001 in binary, what is that? This is 1 times 2 power negative 1 plus 1 times 2 power negative 2, 3, 4, 5, 1 times 2 power negative 5, and I'll skip the details here, but it turns out that it's the right thing. Okay, I should not have messed up. No, I didn't. It's all good. Okay. So hopefully that makes sense. Okay. It's just a question of doing a few examples just to imprint it on your brain. Okay. So how do you do an arbitrary number now? So here's an example. Let's say that I want to convert 13.6875 to binary. That's a 13 here. Okay, so I want to convert this decimal number to binary. What do I do? Well, decimal part, integer part is one way, fractional part is another way, and I just put them together after. So do the integer and fractional parts separately. Okay, so let's do the integer part. Yeah, so after the lecture, I've prepared a little, what I did is I picked out some problems from quizzes from previous years, and I just did a small document with one exercise of each, and I'll break you up into groups, and I'll give you the that practice sheet, and you guys can solve that. You won't have the answers, so you'll have to report back to me and tell me what you got to make sure, and I'll tell you yes or no or whatever. Okay, so okay, so integer part 13. I want 13 in binary. What do I do? Where can we find the video after the meeting? It'll be on YouTube. Yeah, sorry about last time. I put it as a private video. That was not my intention. That was that's not what I wanted to do. But it's they should be available. I saw that some people watch them, so you should be okay. Yeah, it's on YouTube. But you can reach them through Leia. If you go to the Leia distributed documents, there's a link to every lecture there. Okay. Yeah, so that's the way you can access them. Yep. Okay, so integer part, how do I do that? Successive divisions by 2. 13 divided. So the danger here is going too fast. This is the every mistake that I've seen is we're just trying to go too fast. And all 80% of the mistakes going too fast. The ending going too fast, and writing it in the wrong direction. Also classic. Okay, 2 times 6 is 12. Remainder of 1. 6 divided by 2. 2 times 3 is 6. Remainder of 0. 3 divided by 2. 1 times 2 is 2. Remainder of 1. 1 divided by 2. Careful with that. How many times does it go? Does 2 go into 1? Goes 0 times. But there's a remainder of 1. Okay? But then you stop. Okay? So now you read this way. So 13 in binary should be 1101. You can check. 1101 is 2 power 3 plus 2 power 2 plus 2 power 0. Okay? This is 8 plus 4 plus 1, which is 13. Okay? So that's good. Fractional part is different, right? So fractional part, you multiply by 2 successively. I'm going to need a bit more room here, but I'll start here. 0.6875 times 2. It's tempting to cheat. I won't. Get my brain going. That's, sorry. So that should be correct. So it's 4, 1, 2, 3, 4, 1.375. Oh yeah, by the way, so somebody asked about the 0. The 0 is important here, right? When I'm counting, when you're multiplying, you want to know where the decimal point goes. Of course, the 0 here is crucial because I'm counting 4 decimal places here. 1, 2, 3, 4. This is 1.375. 0, right? So this is where it's important. After that, I can drop it. Okay. All right. So my first integer part is right here. I repeat with the fractional part, 0.375 times 2. Now I'm going to continue here. Technology. 0.375 times 2. Don't need that. 2 times 5 is 10, 14, 15, 7. 1, 2, 3, 1, 2, 3. So this is 0.75. Okay, I can drop the 0. Repeat with the fractional part. 0.75 times 2. This is easy. This is 1.5. Right? And then 0.5 times 2. It looks a lot like the other example I did. And if you think a little bit about it, you'll see that they're all going to look a little bit like that near the end. I'll get back to that in a sec. So this is 1.0. I stop because I have no fractional part left. Okay. And so my binary expansion, 0.6875. How do I read it? I remember that the first bit that I get is the closest to the binary point, 0.1011 in binary. Okay. So I've done the integer part, I've done the fractional part, and I just put them together. So 13.6875 in binary is, what did I find earlier? I found 1101. Sorry about that. 1101.1011. Like that. That's it. What does the 2 outside the bracket means? It means it's in binary, right? Just to make sure that I mean, it's all zeros and ones, but if I didn't write it, you could mistake this for some decimal number that just happens to have only zeros and ones in it, right? So this means it's written in binary. Is that okay?
Yes, sir.
Yep. Oh, it was just a yes that it's good? All right.
Yeah, just to confirm that.
Okay,
this
good.
is good. Yeah.
All right. Okay, so this is it for conversions. Okay, so these are the algorithm. When we get to octal and hex, it'll be exactly the same procedure. So we'll just have to divide or multiply by the base. In that case, will be 8 or 16. So it's the same procedure. So I'm moving to addition and multiplication. This is our next topic. Okay, so binary addition and multiplication. Actually, I don't know. Okay, sure, of course. I'm a math teacher, so I'm a geek, I'm a nerd, so I kind of like this, but this is actually kind of fun. To be honest, this is kind of cool. Okay, right. So remember, how does it work in decimal? We write down our two numbers, we start on the right, and we add digits, and if there are carries, there are carries, right? So in decimal, when we learned how to add, what did we need to do? We needed to know how to add any two digits, right? So that's the basic the basic step in the algorithm, right? So need to know sum of any two digits, right? So there's a table, right? 0, 1, 2, 3, which we all know. We don't think about it, but we just learned that, right? And so, for example, if I take 6 and 7, right, in that table, so I need to know what 6 plus 7 is. That's 13, right? So that would be 3 and a carry of 1, right? 3 and a carry. Sorry. Right? So that's when we're adding. Okay, that's fine. That's good. Okay, so when you're doing this addition, right? So if you've got a number and you've got a 6 and you've got a 7, you add them up, then you say 6 plus 7. You need to know that, right? So the algorithm has a table that it reads. It says, okay, 6 and 7, that's 13, so that's 3 and a carry of 1. Okay, and then we just keep on going. Now for binary, there are only two digits, right? So actually it's kind of stupid, right? The table is like super small. Okay, so for binary, the table is really small. Okay, so let's take a look at the table. There are two digits, right? So here's the sum table for the digits, which are the bits. I mean, there's not much to do, right? To learn 0 plus 0, that's 0. 0 plus 1, that's 1. 1 plus 0 is 1. And 1 plus 1 is 2. So that, how do you write 2 in binary, right? It's 1, 0, right? So this is 2 in binary, right? So this is 0 and a carry of 1, right? Now, there's only one other thing we need to know is then when we're adding, if we're adding 1 and 1, and there was a previous carry of 1, then we'll be adding 1, 1, and 1. This one I'll write separately, right? 1 plus 1 plus 1. These are all in binary here. This is 3 in binary, which is written as this, right? 3 in binary. So it's 1 and a carry of 1, right? So in other words, 1 and a carry of 1, okay? So that's all you need to know to add in binary. And then you just repeat the algorithm and that's it, okay? So let's do an example and just see how this goes. I'm gonna do the first one like super slowly, but if you do a few, you see this goes really fast, okay? This goes really, really fast. Okay, so here's an example. So I have to add 1, 1, 1 plus, I'm not gonna write the little 2 here. Everything is in binary, so all in binary, okay? Like I said, when there's possible confusion, we write the little index 2, but otherwise we just won't write it if from the context it's clear what we're doing. Okay, so how do I add? It's the same algorithm as decimal, so it's 1, 1, 1. I put 1, 0, 1 under it, and I add. I start on the right, okay? So 1 plus 1, that's 2, right? Which is 0 and a carry of 1. So that's 0 and a carry of 1, right? Then I add the next column, 1 plus 1 plus 0. This is 0 and a carry of 1. And finally, 1 plus 1 plus 1, as I said, this is 3, so it's 1 and a carry of 1. 1 and a carry of 1. Okay, let's check. Okay, so what is 1, 1, 1 in decimal? If you convert this to decimal, this is
7.
7, correct. 2 power 2, 2 power 1, 2 power 0. This is 7. 1, 0, 1. That's 4 plus 1, which is 5, which is 12, right? And 1, 1, 0, oops, 0, 0. This is 12. That works out, right? It's 8 plus 4. Okay, so that's all good. All right. Now, so let's do another one. Then I need to make a remark about if we're adding several numbers together, which is the only thing that doesn't work very well in binary. So let's do 1, 1, 0, 0, 1, 1, 1, 0, 1 plus 1, 0, 1, 1, 0, 1, 1, 1. Everything is in binary, okay? So let's write this up. 1, 1, 0, 0, 1, 1, 0, 1. Here I have same number of bits, 1, 0, 1, 1, 0, 1, 1, 1. So let's do this. So I start on the right. 1 plus 1, that's 0 and a carry of 1. 0, carry of 1. 1 plus 1, 0, carry of 1. 1 plus 1 plus 1, 1 and a carry of 1. 1 and 1 is 0 and a carry of 1. 1 and 1 is 0 and a carry of 1. 1 and 1 is 0 and a carry of 1. 1 and 1 is 0 and a carry of 1. And 1 and 1 and 1 is 1 and a carry of 1, right? So that should be correct. I hope I didn't mess it up. I may
If
have.
there's a carry, does that mean that we have to? Okay, that means that's why we added the two ones, right?
Sorry, say that again.
The reason why we added the other one is because of the carry, right? At the end.
Yeah.
Right.
So apparently I didn't write down my numbers correctly from my example. So I have no idea if this is correct or not, so I have to check it, okay? Because this is different from my example. So let's see. Checking is like super annoying. It's much longer than just adding them together, but let's just check them just to see. Okay, 11001101. In decimal, this is, oh man, that's big. 2 power 7 plus 2 power 6, 2 power 3, 2 power 2, and 2 power 0. So this is 128 plus 64.
You just use the calculator to calculate it, and it's right.
It's okay on the calculator? Yeah. Okay, good.
Yeah.
Thanks. So, yeah, this is painful. Okay, so this is good. All right. The chances, I mean, if you go, I went quite fast at the end there, but in fact, if you just don't go too fast, chances are you're not going to make a mistake. Okay. So, it just goes very well. Okay, etc. So checked on calculator. Wonderful calculators. Okay. But if you're on a test, in theory, you don't have a calculator, so you can check it by hand if you want, but it's like super long. It's really painful. Okay. Okay, here's now an example which is important because when we're going to multiply, we'll have to do this, okay? So let's say I'm asked to do 1001 plus 1101 plus 110 plus 1011. Now, here is where binary is not so nice, is if you try to do this in the same way that we do it in decimal. So when we're adding several numbers in decimal, if you have less than 10 numbers, or let's say 6 or 7 numbers, you're going to be okay because your carry is going to be only in one column. But if you have more numbers, let's say you have 12 numbers that you're adding, then it's quite possible that when you're adding one single column, you're going to get a total which is bigger than 100. And that means you're going to get carries 2 columns further. We've never done that, right? So we've never seen it, but that's what would happen if you added by hand, like let's say 10 numbers or more. It could happen that you get carries into not just the next column, but in further columns. It's a mess. It's a total mess, okay? So the carries do not behave well with several numbers. For example, try adding 15 numbers in decimal. Carries bigger than, yeah. Hello, sorry. Carries go too far. I don't want to go into this, okay? But if you think about it, if you try it by yourself, you'll see that you can't handle the carries very well. It becomes a big mess. So what do? There's a simple way out, right? You just add numbers 2 at a time and add the next one and add the next one, okay? So it's not really slower. So solution, add 2 at a time. So here's how I'm going to do this. And that's how we're going to do multiplication, which I might not have time to do today. Copy, paste. Okay, so let's say I want to add those together. Okay, so what am I going to do? Sorry, I'm going to add 1001 plus 1101 first. I'll add those two first. So I get 0, carry of 1, 1, 1, 0, carry of 1. Okay, and then I could do, for example, well, a nice way of doing it would be, no, let's not do it like that, but it would be fast. But I'm going to add the next one, right? 1, 1, 0. So let's align those nicely, because otherwise it's going to be a mess. Okay, so this is 0, 1 and 1 is 0, carry of 1. That's 1, carry of 1, 1, 1. Okay, and then I'm going to add the last one, 1, 0, 1, 1. So this is 1, 1, 1, 0, and a carry of 1, 0, 1. And so 1001 plus 1101 plus 110 plus 1011 is equal to 100111. Okay, so what I do is, rather than try to add them all up simultaneously like we're used to do in decimal, so it doesn't work very well in binary. So what you do is you just do 2 at a time, add another one, add another one. So when we're going to do multiplication, which I'm actually going to do now, or I'm not sure. I'm still thinking about it. You'll have to do it this way. Okay. Okay. Let's talk about fractions. There's nothing really to add. Pun not intended. There's really nothing new with fractions, right? It's the same as decimal. So no problem. You just align the points, right? It's the same thing. So there's really nothing new here. So let's say I'm asked to do 11011.01 plus 101.1101. Okay, it's the same thing. You just align the points. This will be 0.1101. I just want to make sure I'm putting all these things correctly. You can put zeros here if you wish, right? If it's easier. And you just go right to left, 1, 0, 0 carry of 1, 0 carry of 1, 1 carry of 1, 0 carry of 1, 0 carry of 1, 0 carry of 1, 0, 1. Yes. I know I'm doing this very quickly, but if you think about it, if you do a few examples, you'll see it's like super simple. Okay? There's just 0 plus 0, 0 plus 1, 1 plus 1, and 1 plus 1 plus 1. That's all you need to know. Okay? So this is it. Okay? So fractions, no fractions, just it's always the same thing. You just align the points and that's it. And you go from right to left and that's it. Okay? So far so good? Is that good? Yeah?
Yep.
Wunderbar. Sehr gut. Okay. I want to do multiplication now. I'll start and we'll see how it goes. Okay. Multiplication. Believe it or not, it's even easier. So I remember when I was in grade school, I don't remember exactly, but I think I got sick at some point and I missed the classes where I was supposed to learn my multiplication tables, right? You know, when 7 times 9 is 63, blah, blah, blah. And my mom got really angry at some point and said, okay, you need to learn them. So I got this little book. On the back of the book, there was the table. I had to learn them. It was really painful. I don't know. I hated that, right? But so you remember, so in decimal, when you're multiplying, you need to know your tables, right? We all learned those, 0, 1, 2, right up. Let's say I'll put 7 here. Actually, we learned them up to 12 for some reason. I don't know why. Well, let's put a 6 here, right? So 6, that's 42, right? 6 times 7 is 42, and all those things. 7 times 9. I need to do this in French. It's 63. 9 times 9 is 81, right? So we had to learn all these multiplications, right? So if you want to multiply numbers, you need to know how to multiply digits. So this 10 by 10 table, and it's like, so, I mean, some stuff is easy in there. But in binary, it's the same thing. So the algorithm to multiply is exactly the same. Now let's learn our tables in binary. And it's like, that's pretty cool. So 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, and 1 times 1 is 1. And we're done. So now we know our multiplication tables, right? That's it. So there is 0 work to be done, okay? So then your question will be, wait, but then why did we bother learning all that horrible decimal table? The answer is, yeah, we could have learned to do it in binary. We could have learned we could multiply in binary, and that would be just as good, right? Except for one thing. So binary is not so good for human beings. So if somebody asks you your address, right, in where do you live? I live at 754 whatever street, blah, blah, blah. If you had to write that down in binary, it's like this huge sequence of zeros and ones, right? And our brain is like not super good to remember these things, right? So if I write down 754, there's a good chance that if I ask you to remember that, you won't be too hard, right? But if I write this instead, right? I said, okay, remember that. it's not so good, right? So binary, it's easy to multiply in binary, yes. There's less stuff to remember in the table, but it's not very convenient for our brain for some reason. Okay, so this is easy to visualize, memorize, not so easy, right? So that might be one of the reasons where working in binary is not so good. And of course, the numbers are much longer. They take up much more space, physical space. If you're writing on paper, that's not so good, right? But anyway, multiplying in binary is like very, very easy. So let's see how this goes. So let's just recall how we did it in decimal. Okay. If I have to do 1, 2, 3, 4 times 263, this is in decimal. What do I do? 1, 2, 3, 4, 2, 6, 3. I might not do the whole thing, but how does it work again? I start on the right, multiply the digits. 3 times 4 is 12. 3 times 3 is 9, and 1 is 10. 2 times 3 is 6, and 1 is 7. 1 times 3 is 3. So that's the first 3 here. Then I move on to the 6, which is actually worth 6 times 10. So I'm going to put a 0 here, shifting, because it's worth 10 times more. And then I repeat. 6 times 4 is 24. 18 and 2 is 20, and so on. And the next one will be that. And then I add them up, right? So this is how it goes. So if I want to do in binary, it's exactly the same thing, except, well, first we saw that multiplying bits is like super easy, right? It's just really, there's no work there. And the shifting is also easy, right? So here's the algorithm to multiply. So I'll just illustrate it. So in binary, this is like super easy. So let's say I want to compute 1101,011 times 10110. Okay, so let's do that. 1 1 0 1 0 1 1. This one I'm going to do more to illustrate the algorithm, so I'm not going to do it properly. If you want, as if I wanted the answer, I'm just gonna, you'll see what I mean in just a sec. So I'm gonna illustrate how we work this out. So what's the algorithm? So I start with this first bit and multiply this bit times the top number. What will I get? 0, right? We can write it out if we want, but it's just going to be a bunch of zeros. So let's just do it. Right? So that's when you multiply with this 0. I move on to the next. So now I have to put a 0 here, right? Because I'm shifting, it's worth twice more, which means a shift to the left. Now 1 times all of this, what do? I just
Copy
write it
it.
down. Yeah, you just copy it down, right? So 1 times everything is just the same, right? So you just write it down. So it's 1 1 0 1 0 1 1. You just, so 0 times the number is 0, right? And 1 times the number is just your number. It's just, there's nothing to do, right? Okay, so I move on to the next. I put 2 zeros here, and I just write down the number. 1 1 0 1 0 1 1, if I didn't mess up. Then there's the 0. I would have just a bunch of zeros. 1 2 3, so that would be, that's 7. And then finally this last one here. Again, I'm not showing you how I would actually do it, because you see that now I'll have to add a whole bunch of binary numbers, which we know is not convenient. Okay, but just to illustrate the algorithm as if it were decimal. So 1, this last one here, I need to put zeros here like this, and then just copy down, just make sure I've got 1 2 3 4, and then I just copy it down. So 1 1 0 1 0 1 1, right? And that would be it. Okay, so zeros give you, multiply, give you 0, 1, just copy down, and you shift accordingly depending on the position. Now, so the only trouble is adding all these. So must do 2 at a time. Okay, so that's the only difference. So let's do 1. I think I have another one here, and then after that I'll stop. Okay, and I'll let you work. So sorry, this is a bit longer than what I usually want to do, but I wanted to stop at a natural place. So, okay, so here's an example where I'm going to do, just if I were asked to do this on a quiz or in a test, this is what I would do. So I guess it's the same example. 1 1 0 1 0 1 1. They're all the same in the end. It doesn't make any difference. Okay, so here's how I would do it. 1 1 0 1 0 1 1 1 0 1 1 0. So I'm multiplying this. So I don't need to write the zeros down, right? It's completely irrelevant. So the first 0 here, I don't bother with. So I'm going to put a 0 here because I'm moving to the next bit. Now I write down my number, 1 1 0 1 0 1 1, because I'm multiplying by 1. Then I move to the next 1 1 1 0 1 0 1 1. I'm writing it right to left because it's easier, right, to place them properly. And now what I do is I add those two numbers immediately. Okay, so I'm going to add those immediately. So I'm going to get 0 1 0 and a carry of 1, 0 carry of 1, 0 carry of 1, 0 carry of 1, 0 carry of 1, 1 carry of 1, 0 carry of 1. Okay? Then I continue my multiplication. So I've got my 0 here. It just gives me 0 all the way. I don't care about it. And I go to this 1. I need to put the correct amount of zeros first, which is 4, right? And then I write down my number 1, 1, 0, 1, 0, 1, 1. Add those up, and I should be okay. So 0, 1, 0, 0, 1, 1, 0, 0 carry of 1, 1, 0 carry of 1, 0 carry of 1. So this is it. I've multiplied these two numbers. Okay, so 1, 1, 0, 1, 0, 1, 1 times 1, 0, 1, 1, 0 is this whole thing. 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0. If I didn't make a mistake, let me check. Looks okay. Of course, you can check with if you have a calculator for this, in this particular context. You can check also by converting to decimal if you wish. It's quite long, okay? Now, the last thing I need to say is, what about fractions? Well, it's exactly the same as in the decimal case. So here is a smaller example, just to finish my last example. So fractions, just like decimal, you count the number of bits in the fractional parts, right? So let's do an example, small example. Let's say I'm asked to do 11.01 times 101.1. Okay, so how does this work? You forget about the point, the binary point, you multiply, and at the end, you put your binary point in the right place. So 1, 1, 0, 1, 1, 0, 1, 1. I'm going to multiply these. Okay. So how does this work again? Start here, 1, 0, 1, 1. Move to the next, 1, 0, 1, 1. Difference from the decimal, I add now. I keep a running total. So 1, 1, 1, 0 carry of 1, 0 carry of 1. Okay. 0 contributes nothing. So now I move to the last one. So I need to put my correct number of zeros here. And I copy down my number, 1, 0, 1, 1. And add 1, 1, 1, 1, 0, 0 carry of 1, 0 carry of 1. Okay. And finally, so now, so this has two digits in the fractional part. This one has one digit, or bit, I should say, sorry. Right? So the factors, one of them has 2 bits, the other one has 1 bit. So in the result, there should be 3 bits. In the fractional part of the result, 3. So that should be the answer. Hopefully that makes sense. Okay, so it's the same thing as decimal. So you look at the number of digits to the right of the points, you add that to get the total number of digits to the right of the point in your answer. Okay. All right, so sorry, this took a little longer than expected, but I think we're good for that. So what I'm going to do now is to put on layout. I'm going to put, you know, it's late. Okay, I'll keep my little practice sheet for next time, actually, you know. And for now, if you want to, I'll just send you to breakout rooms if you want to work. If you're going to leave, I'm not gonna run after you. Haha. Don't worry about it. So you can work on WebWorks or on the assigned problems in the book. That's fine. But it's been a long lecture, so that'll be fine for today. Let me stop the recording.